Everyone, welcome to our video on de Moivre's theorem. So de Moivre's theorem shows us the way to raise a complex number to a power. All right, so what it's telling us is if we have our complex number already in polar form, then if it's raised to an n, what we can do is rewrite it where what it's saying is we should raise the radius to the n. And then since raising something to a power is repeated multiplication, so we just did a multiplication problem. I think these multiplications are actually worse than this theorem. But repeated multiplication, so multiplying the moduli however many times, that's the raising the power. And then it's saying you should add the arguments. Well, if you have n arguments getting added, that's where the n comes in. So we raise the radius to n, and then we multiply. So that's this portion. And then we multiply theta by n. Okay, so if it's raised to a power, it's kind of a nice problem. However, the problem in these is that we first need to convert it into polar form. Okay, so these problems, so we don't want it. So what this theorem does for us is it lets us make it to where we do not actually have to FOIL this out. Okay, because that would take a long time. We don't want to do that. So instead, what we currently have is z is the value that's inside the parentheses that's not raised to the power. And so we need to convert that into polar form. Okay, so 3 to the left and 3 down is right there. Okay, and this is a special triangle, so there's 3 and 3. I'm going to use my special triangle 45, 45, 90 information to speed up the process. So that would be the radius is 3 radical 2. And then our angle theta all the way around to there. Again, it's a 45-degree angle there, or pi quarters as an angle, which puts it right in the middle of quadrant 3. Well, right in the middle of quadrant 3 would be the angle 5 pi quarters. Okay, so that way I can rewrite my z. So the radius goes first, 3 radical 2, and then parentheses, cosine of the angle plus I sine of the angle. Okay, so there's our rewrite of just z. Okay, so we do want it in polar form, which is up there, which I'm currently bolding. Okay, and then now we can use our power. So it's saying we want to raise this to the 8th. Let's go ahead and even put that. I'm going to put it in blue. So what we currently have is, well, again, let's follow the rule. It's saying you should take the radius and raise it to the 8th power. Let's fix that 8. There we go. And then again, big parentheses, cosine. Let's go ahead and use parentheses here. It's saying that angle should get multiplied by 8. And if it helps, you could put a 1 as a placeholder. And then plus I sine. Again, 8 is going to multiply that angle. And then 5 pi quarters. Okay, so there's the big setup. Okay, so z to the 8th, that's what they wanted us to find. That is equal to, all right, so now it's just kind of scratch work. All right, so my 3 radical 2 to the 8th. All right, that's a big number, actually. Okay, so if they're not using a calculator, we could probably do that a little easier. I will do the radical 2, so I think I'll have enough space. So here's my scratch work. The radical 2 part I can raise to the 8th at least. Because radical 2 to the 8th, I would look at that as 2 to the 1/2 and then to the 8th. And remember, so the square root is the same as a half power, and that way I can multiply the powers together. This is the same thing as 2 to the 4th. And then 2 to the 4th, 2, 4, 8, 16. It's 2 times 2 times 2 times 2 is 16. Okay, so that might be something that we could do. However, 3 to the 8th is a large number. So I think what they would write here in the blue would be 3 to the 8th. Oh, let me fix that. 3 to the 8th times 16. Okay, because again, that's a big number. If we needed to use a calculator, we could. Here I had something already ready. Okay, so 3 to the 8th, 6,000. Okay, so not as big as I thought. And then times 16th though. Okay, so that would take a little bit of time, right? We're using the scratch work. Okay, so we'll write that in as a second answer, but for now I'm just gonna say 3 to the 8th times 16, and then parentheses. Now these would reduce here. The 8 and the 4 cancel, so that would have become a 2, and then times 5 is 10. So cosine of 10 pi plus I, it's the same angle. Again, it's always going to be the same angle there. So 10 pi and 10 pi. So you kind of just need to calculate it once. And then after that, we could simplify this further. Okay, so I've got z to the 8th. Okay, so since I did use a calculator to the side, I am going to write 104,976 was that portion there. And then cosine 10 pi is 1 plus I sine of 10 pi is 0. So our final answer is just 104,976. There we go. Okay, so that value right there, raised to the 8th, becomes this number. So it shows a complex number can get raised to a power and become a real number. That can happen. Okay, so interesting. Okay, number two, there's a typo. Okay, so that one, that should have an I right there. Okay, because otherwise it's not a complex number. Okay, so that one should have had an I, sorry. Okay, but either way, it follows the same process as the last problem. So I would just say, well, whatever's inside that parentheses is the z. There we are. And then we would need to convert that to polar form. So we have 5 radical 3 to the right, and then up 15. Okay, so somewhere about there, we'll say. Okay, and I still have a right triangle, so that means I could still use Pythagorean's theorem to get my answer. Okay, so we've got 5 radical 3 squared plus 15 squared would be r squared. 5 squared and radical 3 squared would be 25 times 3, so that's 75. Plus 15 squared is 225. That becomes 300. Then 300, looks like that should simplify. So 300, when we do the square rooting, I remember plus or minus, but in this case, we want the plus. So we'd always want them positive. Okay, but 300 is the same thing as 100 times 3. So it looks like this should be 10 radical 3. Okay, so more scratch work than the last one. This is also a special triangle. Okay, so you might have spotted it. Okay, so but that is our r. Okay, so all of that was just to get r. And then we do need the angle as well. Okay, so the angle, let's do our tangent. Okay, so our tangent of theta would equal the opposite, so the imaginary part. So we've got 15 over the adjacent, 5 radical 3. This simplifies to be 3 over radical 3. Rationalizing that, okay, so if we multiply the top and bottom by radical 3, the 3 in the numerator would cancel out with those once it simplifies, so we're left with just radical 3. Okay, so then now I can figure out what that angle is. We are in quadrant 1. Where tangent has radical 3 in it would be where I have the angle pi thirds. Okay, so we found it. So we have our angle as well. Okay, so now that means I can finally rewrite it. So we've got z is equal to whatever the radius is, so 10 radical 3, and then cosine of the angle plus I sine of the same angle. Okay, and then now, let me kind of block that off. Now we can raise it to the power. So -4 is the power, which means, again, the radius itself gets raised to that power. and then the big parentheses, cosine, the angles get multiplied by that power. Okay, so I'm going to just write that as -4 when multiply the pi. So I'm just going to instantly just write it as -4 pi thirds plus I sine of -4 pi thirds. Okay, so the radii or the radius gets raised to the power, and then the angles get multiplied by the whatever the original power was. Okay, so that's what it looks like. And then now, just like the last problem, okay, so z to the -4. We would want to do the simplifying. Remember, the negative power would just flip that 10 over radical 3. I'm going to do my scratch work again, way down here. So 10 to the 4th would be 10,000. Radical 3 to the 4th, I'm going to do my same strategy as last time. I know that that would become just 3 squared, which is 9. So when 10,000 multiplies 9, okay, so that would be, so when these multiply, we would have 90,000. Okay, so the negative power, though, would just put it down below. So 1 over 90,000, like so. And then the cosine of -4 pi thirds, so we would want to be able to evaluate it. Okay, so again, just kind of scratch work down below. -4 pi thirds would put us in quadrant 2. Right there. Okay, so, and from there I could say, well, cosine would be -1/2 plus I sine of -4 pi thirds, still in quadrant 2, would be positive radical 3/2. Okay, and so afterwards they would distribute that, or at least I believe they would distribute this fraction. So we would have -1 over 180,000, and then plus, still distributing. I'm gonna put the I right there still. I radical 3 over 180,000. Okay, so that is the answer this time. Okay, so we get weird answers too. So the first one was a nice whole number. This one, we get a weird fraction and still a complex part. Okay, so that can happen too. That's fine. Whatever. We followed the rule. Okay, and again, it's a lot easier than even this. So flipping it and foiling it, that would take forever. Okay, so we'd rather... This also took a while, but it's still faster than foiling, I think. You could try it if you want. Go ahead. Okay, so you should get the same thing. Okay, anyway, but that's it. So that's how Dumov's theorem works. Okay, so again, the radius gets raised to the power, and then the angle gets multiplied by whatever the original power was. And then simplify. Okay, so thanks for watching. We'll put a pause and do our next video for the next topic. See you then.